In present times, it's more and more important to reduce your energy effort, reduce your material input, and increase your quality in the production.
Yeah, and Mahlo is always developing systems to help you to achieve all these goals. Today we like to show you a new system which is called Orthopac RXVMC-20. It is a straightening machine designed especially to straighten distortion sensitive knitted goods. And now we like to show you how it works.
So let's go.
Let's go. Hello and servus from Bavaria. After a long summer break, we are now back with the latest mCast. We are the Mahlo mCast team. My name is Thomas Höpfel.
And my name is Christian Matthias, and I greet you as well.
Today we like to talk with you about our latest development in distortion correction. This is our straightening concept for distorted sensitive knitwear, which we call Orthopac RXVMC-20. It was for the first time displayed during the exhibition in Milano, and we are very happy with the response we got there. We had a lot of positive feedback from our customers. We raised a lot of interest, and we from the sales side we had a lot of interesting discussions. I think the same was on the application technology side.
Yeah, that's true. A lot of people were interested in the new concept, also because we discussed the problems with our customers to create the solution in this kind of machine.
Yeah, and so all in all, we consider this now a complete league of its own when it comes to the correction of distortion sensitive knitwear.
The Premier League.
This is the machine as it looks now. This is exactly what we also displayed during the show. I hope that some of you who are now watching this mCast are or have been at our booth, so that you may have seen it already. And today we like to give you more details about it. Yeah.
Here now we can see the technical layout for the machine here. We took our standard RVMC and take all the advantages we can give, because now we have here not even only the eyes at the outlet like it's a normal condition. We placed here our scanner systems at the inlet of the machine.
And you can see that the machine consists now of two components. At first there's the entry straightener. It is equipped with the distortion system at the inlet, so whenever a distortion or a fabric is coming with distortion in, we can see already the distortion configuration at the inlet of the product. Then it goes to the skew and to the bow roller, and then from there it goes to the second component of the machine.
So at first we talk about the feed forward controller. Here we can detect from the very beginning of the fabric at the entrance. After that concept, it comes down to the standard machine straightening concept, where we have the scanner systems at the exit.
Yeah. Okay, why have we now created such a machine? We have created such a machine because there is some room for optimization when it comes to straightening of knits. Knits have, like I mentioned already at the beginning, a big distortion dynamic. Distortion dynamic means that the distortion is changing frequently in an abrupt way from, let's say, left side forward to right side forward, or from a leg-in bow to a forward bow. This is the distortion dynamic. Where does it come from?
During the process, of course. Knitwear likes to be moved and experience a lot of movement during the process. So beginning at the knitwear process itself in tube condition, it will always have some kind of movement in here, unrolling. Then it goes forward to the tube cutting position, where of course every dynamic you can imagine can happen to this knitwear. Then it comes to the water-based finishing process, like the dyeing process, or afterwards the drying process, of course. And then
and in between you still have, after the dyeing jets, you need to open the material again, and then you go over a rope opener, which again, for sure, you have to bring it up in relatively big heights, you know, to open this. And there you have distortion dynamic from one side to the other, constantly created.
So when you open it from tube condition into web condition, there is a lot of dynamics coming into the fabric.
But even more difficult for the weft straightener, these are the seams which you need to create between the individual pieces in order to form a longer lot of fabric, so that you can run it continuously through the following continuous processes, like on the center frame.
So here we know that knitted fabric good is approximately 100 to 100 meter long, and to run it constantly through your standard process, you sew a lot of them pieces together to run the standard frame during your shift.
Yeah, and when you look at these fabric constructions, when you have a single jersey, when you have a piqué fabric, when you have an interlock fabric or other materials, it is very difficult to make a straight seam. So you cannot bring the courses parallel to each other. This is very difficult. In woven goods, you can tear the fabric, you can make a straight seam, and then you will have not big variations in terms of distortions when you enter the weft straightener. But on knitted fabrics, this is not possible, and after a suddenly the distortion can completely change from right side forward to left side forward, and this is happening again and again and again. And why is this now creating a problem? When you look now to the weft straightener on this slide, you can see that on a conventional weft straightener, the distortion system is located at the exit end of the machine.
So what this means, we are always late. The seam is running through the scanner part, and afterwards we can't change the position of the fabric.
The weft straightener will only start when the seam has passed the detection system. It will then give impulses to the skew and to the bow roller to move them to a certain position. Yeah? And this is in the end then creating a certain dead time, you know. And a lot of material is passing through the straightener and is not completely corrected to a zero distortion.
So after every seam, and we talked about a lot of seams compounded together, we can assume that there is a lot of meters that we lose to get to a perfect position, to get straightened.
And this is built into the concept of a conventional weft straightener, like we have installed thousands in the industry, because you always need to have a detection system at the end to create a closed loop control. And therefore, this configuration was created. It is doing a good job, but we feel with our actual machine, we have the opportunity really to improve further.
So we talked with our customers, and we talked with them what the problem is here and how much fabric is affected by this normal concept or by the seaming problem.
Yeah.
We asked them how much of your seams are maybe bad or not in good condition, and create those different kind of distortions after it.
And here we have now some examples. We split this up in single jersey, in interlock, in piqué, and in jersey crepe materials. Yeah, and we assume that those materials are run over a center frame with capacity of about 10 tons per day. This means, for example, for single jersey, that you have approximately 10 million meters per year. When you calculate later on, You can see all the data. I mean, this is anyhow on the
Open
slide.
source,
We
yeah.
do not have to read all this, but you can see that you have 10 million meters of fabric produced. If now only 5% of the seams are not made sufficient or in a good straight order, you have about 4,167 pieces which are affected, which are not completely within the distortion tolerance. This means you have about 500,000 meters affected fabric. For sure, on the other materials, this is a little bit lower because
this can affect different kind of knitted fabric in different ways. We know that single jersey has its properties and its behavior. We know that jersey crepe or piqué itself behave in a different way with the distortion.
On the jersey crepe, you hardly can see any. The knitted courses are very difficult really to see. You never will
really
get
difficult
them parallel.
for the machine.
And therefore, we also said that we have approximately 50% of all the seams out of order.
Very conservative view is here that we assume at a minimum how much percentage per year of the seam are affected here. So this can vary. This is best known by yourself in your production, how much knitted fabric is affected.
Yeah, and then for sure we talk with our customers, what are they doing when they have this kind of material which is not fully not fully corrected and still leaving the stanter frame with too big residual distortions. And there the answer was a little bit surprising, at least to me. Most of the people, they say for them it is the best to re-sew the whole thing, to open the seams, to sew it as straight as possible again, and to run it again through the stanter frame.
Yeah. Yeah. Because if you can require your quality tolerances, you have to at minimum reseam it and put them out of your quality A area of goods and run it again to the stanter frame. Or even the next possibility is here. Maybe you have not a chance to move it again through your stanter because you don't have the capacity at all.
It's often a bottleneck. The stanter frame is very often a bottleneck in the production.
So here maybe you have to sell it to a lower price because of course it is not straightened at all.
And the third possibility, which sometimes also needs to be looked at, is to cut out the affected meterage, you know, and then it is a total loss for the producer of the.
And I think nobody wants to do that.
But it was very clearly when we talked with our customer that most of them resew the material and run it a second time through the stanter frame. And now in this slide, in this chart, we are highlighting the costs which this kind of rework is creating for our customer. When you look, we call it to reproduce the fabric, so this means to run it a second time through the stanter frame with hopefully better seams between the pieces. This creates costs of 100,000 euros when it comes to single jersey. The other values,
at least,
I think you can read by yourself.
Yeah. So here we know now the percentage how much seams are not good. So those seams create your new costs because of you have to run it through the stanter again.
And when you are forced really to accept a lower price for those pieces which are affected, then you can also see from this slide that for a single jersey, for example, it comes up to 200,000 euros in costs per year. Yeah? And when you have to accept to cut it out completely and to have a total loss, this is even a higher loss you make. And so after seeing these values, it's clear to me why most of the people opted for reproducing the material.
Not even talking about that you have to use this material and effort and energy again to create those losses of the goods. So here we are focused only on the problem, the seaming potential, what can be improved, but you maybe can assume that there are a lot of improvements which can be made by this machine.
Yeah. What we see now on the slide, these are the costs which are created. And now, when we are using our concept, then we have put into the, we are doing it in this way, what we can see here. On the left side, you see now what is happening at the entrance. We explained this already. The fabric is coming in, the seam is detected, or not the seam, but the distortion after the seam is immediately detected, and then we have an intelligent feed-forward control. We move automatically the skew and the bow rollers to the positions which are necessary to overcome the distortions which are detected at the entrance. So we do not have to wait until the fabric arrives at the end. And then you can see that the biggest part of the distortion is already gone.
Eliminated.
At that position when the fabric is leaving the first part of the straightener. Then it goes to the second part.
But we don't stop here, because when we talk about the entrance concept, we maybe straightened most straightening or most distortion is eliminated. But afterwards, we don't even know what is the exact position. So here we have our lower part of the machine, the normal concept with the eyes and the detections at the exit of the lower part, where we fine-tune the residual distortion, which is mostly not very big because we feed forward control it, but here we close loop control it. So this means we react to the minimum distortion and eliminate it.
And the good thing is, after this machine, the fabric will be perfectly straight, but always already from the first centimeter after a new configuration is entering into the straightener, because we see up front, we put the skew rollers where we believe they should be. If there is still some distortion left, the closed loop control with the fine-tuned straightener at the end will do the residual job, and really the fabric comes out always straight.
So here we know how much we can improve by straightening it from the very beginning, which now in the next slide creates a new calculation how much meters loss we can reduce.
Yeah, and here we have now in the end the possible cost savings in comparison using a conventional Weft straightener with the exit, with the detection system at the exit.
And the new RXVMC
with
both.
With both, at the entrance and at the exit. And there you can see that we very conservatively, we assume that we can create or that we can reduce the costs by 50%.
Minimum
50%.
Again, 50%. Very conservative.
And then you have cost savings. And then when you put all, in this case now, the 4 examples all together, and because nobody is just running single jersey constantly on the stand frame, so you have to put everything together and make a mix calculation. And then you will see that depending on your product mix, the possible cost savings will be between 50,000 and maybe 150,000 euros per year.
And again, this is only by regarding and viewing only about the seams.
We did not calculate into this formula here our savings, which are then possible by reducing the standard distortion dynamic which is created throughout the processes on dyeing and on finishing.
Yes.
So please consider this when you are next time are talking about a new investment in a straightening system for knitted goods, because we are sure with what we have explained now, we will have a return of investment of this price difference between a conventional straightener and this new concept within, let's say, half a year. And from this moment on, for the next 20 years, this machine will constantly earn money for you as our customer.
Yeah, because it reduces from the very beginning of the entrance the distortion and improves the quality. So this means we don't lose.
Yeah, and you have to see it in this way. You have a higher quality on your product, and every meter which does not need to be reprocessed saves us energy, and energy is now a very important topic and will be in the future even more. So please think about it. There might be a higher investment costs for such a machine, but in the end, you, over the long term, over the usage of such a machine over 10 to 20 years, yeah, you will have a much higher return of investment, and you also will have the trust from your customers that you are supplying absolutely straight fabric. And that's our message for today.
So if you're now interested in the machine and maybe you want to get yourself an impression, so please contact us.
Yeah.
We are always there. We can offer you all information. We can talk about the concept itself, or maybe at your personal production here. And if you like it, please leave a subscription or maybe a comment.
Yeah, you will find it down there. Yeah. We would be very happy if we get some feedback from your side. If you have questions, we are always at your disposal. Okay, so goodbye from Bavaria. Have a good time. Yeah, see you next time. Goodbye.